both sneezing and coughing help protect your air passageways by keeping unwanted particles out. There's also what's called the patellar reflex. When you go on a checkup, often the doctor taps your knee with a rubber hammer. What happens next? Without thinking, your leg automatically kicks or straightens. The doctor is simply testing your patellar reflex, which is also known as the deep tendon reflex or DTR. In this checkup, the doctor is in fact tapping your patellar tendon. The tap causes you to stretch the tendon, which in turn also stretches the thigh muscles connected to it. The message is sent to your spinal cord, which in turn immediately sends back a signal to your muscles to contract. This is why your leg kicks. There are many other reflexes. As for your patellar reflex, it's important because without it, you wouldn't be able to balance and stand straight. This is because the strong pull of gravity can actually cause your knees to bend slightly. But your patellar reflex keeps your knees in place, so you remain standing.
Sanibonani, Dumelang, hello and welcome to Tenfold Live. I am your host, Pio Matebula, and today we have an awesome episode lined up just for you. But before I get into that episode, let's just thank our sponsors, Liberty, for sponsoring every single thing that you see right now. And without them, this all wouldn't be possible. So thank you so much, Liberty. And now for you guys to connect with us and ask us all those questions that you're struggling with, you need to connect with us on all our social media platforms. That's right. We have our app. It's called Tenfold Education, and you can find it on iOS or Play Store, or you can connect with us on WhatsApp and chat to our dot decks, and then you can also connect with us on our YouTube channel. It's called Mindset Learn. So for all your questions and all the question papers that you've been struggling with, you can just connect with us right over there. For now, I'm going to hand over to our main host, Buddha.
Right, thank you very much. Very, very warm welcome to all of you guys. Thank you for joining us. My name is Sibusiso, and as always, I'm very, very excited to be with you guys on another edition of Tenfold Live that promises to be an eye-opening session that is going to help you with a lot of concepts. On today's program, we've got a lot of different concepts that we're going to be looking at, so I'm very excited to start working on those. Like, remember, as we always encourage you, please get as many people to join us on this show that is proudly brought to you with lots of love by Liberty. We're still expressing how grateful we are for all the love that Liberty has actually extended to us and the opportunities that they're giving us. We're now going to go to the first question that you guys sent to us. Remember, we are answering the questions that you sent to us. In today's program, we'll get a chance to look at questions that involve functions and inverses. There's a lot of questions I saw that are engaged on the concept of analytical geometry of circles and those kinds of things. They're very, very exciting, and they're eye-opening questions, including Euclidean geometry. Let's go to our first question. All right. So this is question 4 that is just worth 6 marks, and it reads as follows. It says to us, 2 concentric circles with a common center O have radii of 5 centimeters and 8.5 centimeters respectively. QR equals to 6 centimeters and OT is perpendicular to PS. Determine the length of PS. Okay, cool. Now let's try and see how we can analyze this opening statement that has been given to us and try to understand what is the meaning of each part that stands out. First of all, we are told that these are concentric circles, right? So when you're looking at concentric, it means that these circles are circles that share a center, such that one circle is drawn inside. You've got the external circuit, and then you also have the internal circuit. So the one that is inside is drawn such that the center of the inside circle is going to be the same as the center of the circle outside, okay? That's why you were told that they actually share a common center O. Now, we are given 2 values here, the radii of 5 centimeters and another radii, or the radius of 8.5 centimeters, okay? So obviously, the one of 5 is definitely going to be the radius of the circle that is inside, the smaller one. So I'm going to quickly put the 5 centimeters here as the value of the radius, which in this case is OR. I could have used OQ if I wanted, but I'll just use OR for this particular instance. Now, there is another radius of 8.5 centimeters that the examiner is giving to us, right? They gave us an 8.5 centimeter radius. So I'm going to use a different color just to highlight that if we joined this point O to the point P, we're simply going to have the radius OP, which means that is going to have a length of exactly 8.5 centimeters. So now we've got the radius OP, and now we've got also the radius OR, right? Now we are required to work out the length of PS, which is the chord of the bigger circle, the circle outside, the distance from here all the way to there. We want to figure out what the length of that chord is, right? Now, for us to be able to do that, what we need to do is, first of all, be smart about what is going on. Since we were told that the chord QR, right, has a length of 6 centimeters, it means we can start working from the inside circle to try and figure out what the length of OT is. And then we can use that OT in triangle OPT and figure out what the length of PT is going to be, and that should help us to be able to figure out what the length of the big chord PS is going to be, right? Now, my argument will start first of all with me arguing the length of TR. Why? I'm interested in working with this triangle here, right? I want to use Pythagoras in this little triangle that we have here. We can see that it's the right angle triangle, so we can use it to figure out the length of OT. However, we don't know what the length of TR is. This is where your Euclidean geometry begins. So you're going to have to start arguing that QT and TR are equal because a line from center perpendicular to a chord will always bisect the chord. It will cut the chord into 2 equal pieces, and that will help us get TR, which we can use in the theorem of Pythagoras, right? So I'm going to begin by saying, first of all, QT is equal to TR. The length of QT and TR are simply equal to each other. What's the reason for this? Well, a perpendicular from center, right? A perpendicular from center bisects chord. Perpendicular from center will always bisect the chord. Now that means that we can then claim that the length of QT, right, will be the same as the length of TR, and they will both be equal to 3 centimeters, because we were told that the length of the entire chord QT is 6 centimeters. This is what we were told in the opening statement, right? So that is very important for you to keep in mind, what you know and what you can do with what you are given. Okay, so I'm going to simply put 3 centimeters as the length of TR. Now I'm going to use this information to try and figure out what the length of the line OT is going to be. So in triangle, this is you being nice now, in triangle OTR, okay, we can then see clearly that OT squared is going to be OR squared minus TR squared. And this information comes from the theorem of Pythagoras. Okay, this is Pythag. Very important. Now, since I know that OR is 5, right, and I know that TR is 3, we can then clearly see we're going to have 25 minus 9, which is going to leave us with the length of 16. So if OT squared is 16, therefore we can conclude that the length of OT is going to be 4 centimeters, right? That's the length of the line from O to T, right? Now I'm going to transfer this information and start working with the green triangle. The green triangle is a triangle you're going to get by joining O to P and then using the very same line OT we found and the line PT to try and figure out what the length of PT is. If we know that, we can extend it to TS, and then that means we will then be able to get the entire length of the chord PS, right? That's where I'm going to work. What do I have so far? Well, I know that this is 8.5 centimeters from the given statement. If T1 is 90, obviously T2 and T1 are the same, so that means T1 is also going to be 90 degrees, and then we just found that the length of this is going to be 4. So we can then work out what the length of the chord, the part PT is going to be, right? So I'll be working in triangle OPT. But firstly, I'm going to ask the examiner to allow me to construct something, right? Be nice. Tell us what you want us to do. So construction, join, right, O to P, so that we've got a complete triangle. Very important. So now in the triangle which is created, which is going to be OPT, that's the big triangle, the green triangle in OPT, the bigger triangle on the left. We know that we can apply the theorem of Pythagoras because angle T1 is also going to be 90 degrees, okay? But we will then say the length of the line at the bottom, which is the line PT, okay? So PT squared will be equal to OP, the radius, squared minus OT squared. Where does this come from? This comes from the theorem of Pythagoras. Okay, so what is the length of OP? That is actually 8.5 centimeters squared. And then we have to take away what we just found, which is 4 squared. And then we're going to get the answer to what that is. Don't be ashamed to take your calculator. I'm going to call the calculator now and try to figure out what the answer is going to be to the difference between those two squares. So 8.5 squared minus 4 squared, which is 16, gives us an answer of 56 and a quarter, right? If you press the SD button, it's just going to give you 56.25. Okay, that's 56.25. Therefore, PT is going to be the square root of that. All right, let's go and find what is the square root of the answer, alphabet answer. And then if you just press the equality sign, you're then going to get an answer of 7.5, right? 7.5 becomes the answer, which can be expressed in decimals as 15.5. If you just press the shift button and then you press this button, you change it to a 2 decimal value, which is 7.5. Okay, so PT becomes 7.5 centimeters. Now, where you guys might lose marks, is where you fail to argue that if PT is 7.5, then PT is equal to TS, which will then help you to work out the length of that entire chord. Don't be limited only to this, or do not just take that PT and transfer it to TS without making a Euclidean geometry argument. Remember, every time you're going to use a theorem, such as this particular theorem that says a line from the center that is perpendicular to the chord will bisect the chord. If you don't argue it, you may forfeit the mark. So always make sure you state everything clearly. Okay, cool. So I'm going to argue that quickly. Right. So then that means that I'm then going to say, but PT, right, is equal to TS. Why? Because a perpendicular line from the center, okay, bisects a chord. We already know that those two lines are perpendicular. They told us, right? Therefore, PS is going to be the 7.5 we got multiplied by 2. And then in conclusion, our PS is going to be 15 centimeters. And that will be the solution to this awesome question. Very, very basic, absolutely straightforward. It's not at all challenging as long as you understand what is going on with your Euclidean geometry, particularly theorem 1, that says a line from center perpendicular to a chord will bisect the chord. You use that to make the arguments of the fact that one piece is equal to another piece, and then you also use the fact that you've got a 90 to use the theorem of Pythagoras to try and work out what the missing side is going to be. Very nice question indeed. I hope it has helped you to see how you could have worked out the length of the chord PS. We're coming back with a lot more. Don't go anywhere. We'll be right back.
Did you know that the fastest muscles in your body are the eye muscles? The eyes are able to move in any direction within a split second and can flick sideways to notice an object without you consciously deciding to do so. It is also said that these muscles are 100 times stronger than they need to be to accomplish their task.
Mindsetters, get your grade 12 exam workbooks now. Ask for them at CNA, SPAR, and Pick n Pay stores. You'll find up-to-date CAPS content, past paper downloads, hours and hours of specially paired online video lessons, and so much more. At only 129 Rand, what are you waiting for? Get yours now.
Welcome back, everybody. Yes, we are still here, and we are available on all our social media platforms. So do connect with us because this is an interactive show. But before I tell you about our social media platforms, remember, guys, that this show is interactive, so you need to keep on sending those questions. But let's just thank our sponsors, Liberty, for making all of this possible. Thank you once again, Liberty, for making everything that we've seen right now possible. So yes, guys, you do connect with us on our app. It's called Tenfold Education, and you can find it on the iOS or Play Store. And then you can just, send a young text to our bot. It's called Text on WhatsApp, or you can just stream on YouTube. Stream on YouTube. We are Mindset Land, so don't hesitate, guys. Just send through those questions. Send through whatever you're struggling with. We've got the right people to help you out. So I'm going to give it over to Spoo on the other side. Spoo, Tatinda.
Thank you very much. Thank you. Welcome back, guys, and thank you for staying with Tenfold Live. Like I said, my name is Sibusiso, and we're continuing taking your question on mathematics across any concept that troubles you. Our next question is a question that is based on analytical geometry on a show that is proudly brought to you by Liberty. Let's go and see what this question actually says. A big shout out goes out to Liberty. And thank you guys for being with us. All right, cool. Now, this question reads as follows. It says to us, given the diagram with two concentric circles with their centers at the origin, and point T and R, -12:9, on the circumference of the outer circle. Point S lies on the smaller circle with ST equal to 3. All right? Question 2.1 says, prove that the equation of the outer circle can be given by x squared plus y squared equals 225. Okay, cool. So now what you need to know is what can you do if you are asked to work out the equation of a circle. Now you'll notice that we've got two circles here, right? There's one that is on the outside. How much information do we know about it? Well, we know two things. First of all, we know there's a point R on that particular circle, and the coordinates of R are given to us as negative 12 and 9. And we also know that there's a point T that is also on that particular circle. So if I'm just paying attention to the outside circle alone, right, and I try to just be innovative, just to draw the circle on its own, what do I know? I know that the center is at the origin, which is the point 00. I also know that there's a random point on this with coordinates negative 12 is to 9, okay? If I'm looking for the equation of any circle that is in this form, the formula is always going to be x squared plus y squared equals to r squared. Now, all you need to do is just find either the length of the radius to substitute for r, or find a point that the graph is passing through and substitute for x and y. Now, we were told that this graph, this particular circle passes through the point negative 12 is to 9. So wherever I see x, I'm just going to sub that value of negative 12. Okay, I'll have negative 12 squared here. And then wherever I see y, I'm going to sub the number 9, right? 9 squared equals to r squared. So this is just going to assist me to figure out what the length of the radius is in this particular case, okay? So if you just go to your calculator and you try and work out what is the value of a negative 12 squared, that is negative 12, close bracket, and then you're just going to square it, right? And then you have to add this to 9 squared. What is the answer that you're getting? You're getting a value of 225, okay? So I'm getting 225 as the value of r squared. I don't even need to work out what the radius is going to be. Just in case you were interested in knowing what the radius is, you could take the square root on both sides, but we didn't really need to work out the value of the radius. Therefore, once you've got r squared, we can then conclude that the equation is going to be x squared plus y squared equals to 225, which is exactly what they were asking us to actually prove. All right, now let's move on to the second part of this question. The second part says, hence or otherwise determine the equation of the small circle, right? Now, I want us to go back again and think about the small circle. Two things that I want us to take into consideration. Let's go back to the small circle. Now, the small circle is the circle that is inside. Let's use the white marker to actually draw that one. It's a little bit smaller than the first circle, okay? It is inside, okay? It is the circle that is inside. All right, it also has the center at the origin. That means its equation will also be x squared plus y squared equals to r squared. Now, we were not told about any point that it's passing through, except for the point S, right? So we know that it's passing through a point S here. There's a point S that this particular circle passes through. Now, we don't have all the coordinates of S. We don't know much. If we knew what the coordinates of S are, we would then know what the length of the radius is going to be, which we can then substitute for the value of R. However, we were told that the distance between point S and point T, immediately below point S, is actually 3 units. This information was given to us in the opening statement right there. Okay, we've got ST equals to 3 units. Now, if this portion is 3 units, okay, and I know the radius of the bigger circle, okay, we know the radius of the bigger circle from the center coming all the way down until the center, and we know it's the square root of 225, which if you want to confirm, you can just work out the square root of alphabet, not alphabet, but alpha answer, we get an answer of 15. So if the square root of 225 is 15, that will mean that the radius of the bigger circle, right, the bigger one, okay, is 15. Now, if r of the bigger circle is 15, but the distance between S and T is 3, that will mean that the radius of the smaller circle will then have to be 12, because the 12 plus the 3 will then give you the 15 that you have as the radius of the bigger circle. It's not a complicated thing to see. The radius of the bigger circle is exactly 15. The radius of the small circle has to be 12. Why? Because the distance between S and T is 3 units. So that when you add the 12 and the 3, you're going to get the 15. So that's all I need. Once I know the radius is 12, I'm actually done, okay? So I'm then simply going to say, okay, the new circle has the equation x squared added with y squared equals to r squared. That's the equation that we're using if you're trying to figure out the equation of a circle that has a center at the origin. What is the radius? We just found that the radius is 12. So that means we're going to have x squared plus y squared is 12 squared, which is just going to give you a value of 144. And that is the equation of the smaller circle. Question 2.3 says, if the equation of the smaller circle is x squared plus y squared minus 144 equals to 0, determine the area of the shaded part. Okay, cool. Now, first of all, this actually makes me happy because this is exactly what I have from my previous question. If my equation didn't look like that, I would have a big problem because it would mean that I'm looking at the wrong answer, okay? But then let's discuss what we're looking at here. We've got two circles. We're trying to figure out the area of the shaded region. Now, this is going to be easy. Once you realize that you've got the outside circle, right? And then you've got the smaller inside circle. What you're trying to find is the area of the shaded region, which is all this part that you see here between the two circles, right? This is the area we're trying to figure out. Now, the area of this shaded region is easy. It's like, imagine if you had the full area. Let me draw it this way. Imagine if you had the full area, which is the yellow area. If you had the full yellow area, okay, that means you will be having the area of the bigger circle, okay? And then you just go inside this thing. You then create a little smaller portion, and then you delete this. You just delete this part, right? What have you done? You have removed part of the area that you had when you started. Remember, you started with the yellow circle, which was complete. The area of the yellow circle will be something we can work out by using pi radius squared. Pi r squared will give us the area of the outside circle. But then the empty space that's just left in the middle is just the area of the small circle, right? Which is just this portion here. So what remains outside will just simply be the area of the big circle minus the area of the small circle. It's like you have removed the small circle inside the big circle. So once we've got those two, we can then take the difference between them, the smaller circle, right, which is going to be pi multiplied by the radius squared. The difference between the two will just give me the area of the shaded region. And if you think about it, just think about it. Imagine if you had a complete circle, and then you're removing inside the bigger one, right, the complete one. Just remove a smaller circle. The outside part will remain. That part that looks like a donut will remain. That's how you work out the area of the shaded region. Okay, it's the outside shape minus the one that is inside. So the formula for the area of the shaded portion, area of the shaded region, which is what they're asking, shaded part, that's how they're actually phrasing this, will be the area of the bigger circle minus the area of the smaller circle. Okay, formula for calculating area is pi r squared. Formula for calculating area is pi r squared. You'll notice that the difference between the two is the length of the radius. Pi is pi. I can take it out as a common factor and just have r squared minus little r squared, okay? So pi, I'll keep it as pi. What's the length of the radius of the outer circle? We said it's 15 squared. The one inside is 12 squared. If you take the difference between the two, remember 15 squared is 225. You're just looking at 225 because 15 squared is 225, okay? And then we want to subtract 144, which comes from 12 squared. Okay, we end up with a value of 81. So this is actually going to be 81 pi. So the final answer is 81 pi square units. Now, it is at this point that you need to see what they're asking you. Did they specify that you must round off to 2 decimal places or not? If they're not saying anything, you can leave it as 81 pi square units, or you can take it to the product of 81 and pi, which is what you will get when you multiply 81 and pi. Okay, let's go and say 81 multiplied by pi, and then you'll get an answer of 81 pi, which is equivalent to 254.47. Okay, approximately 254 point, what is this? This is actually 254.47. Yes, 0.47 square units. They didn't tell you the units, so it's just square units, and that will be the area of the shaded region. Very important and absolutely easy. I hope you guys see what you had to do. Just work out the area of the outside shape and remove the area of the inside shape. The one outside and then minus the one inside. It's going to leave just that section there. That is the shaded part. Very important. All right, cool. So let's try and go to the next question. Now, this one is actually a very nice question that is based on functions. Let's see what the statement is on this particular question. The statement reads as follows. It says to us here, the graph of f of x is a into x minus p squared plus q, where a, p, and q are constants, is given below. Point E, F, and C are its intercepts with the coordinates axis. All right. A is the point, -4 is to 5, is a reflection of C across the axis of symmetry of F. D is a point on the graph such that the straight line through A and D has the equation g of x is negative 2x minus 3. Okay, cool. So the first question we are asked to do here or answer is to write down the coordinates of C. Now let's discuss a few things about what they're asking us to work out here. They want us to write down the coordinates of the point C. Now when you're writing the coordinates, it means that the words, you see the words write down, it means the answer should be straightforward. It's somewhere in front of you. And if you look at this, we know that the coordinates of this point here is negative 4 is to 5. And then we were told that point C is the reflection, right, of point A by the axis of symmetry. Reflection, very important for you to keep that in mind. Okay, the mirror image, okay, by what? By the axis of symmetry. So very important. So what is the axis of symmetry? Let's try and draw the axis of symmetry. The axis of symmetry will be the straight line that will pass through the turning point of this graph and go straight down. I'm not sure if it's going to share an x value with the straight line, but the axis of symmetry is the line that we're currently looking at. It's the line that divides a graph into two equal pieces. Very important. So that means the distance from point A, okay, to the axis of symmetry should be the same as the distance from the axis of symmetry to point C. They all have to be the same. They have to be equidistant from the point which happens to be the middle. That's where the axis of symmetry is passing, right? Now, if I want to write the coordinates here, I'm simply going to say, okay, obviously, the x coordinate, since this lies on the x-axis, will then have to be 0, right? But then if that's 0, if x is 0, the y value will be the same because they're just equidistant from left to right. If the y value is 5 at point A, it means C must also have a y value of 5. However, don't forget the fact that the distance from the green line to point A should be the same as the distance from the green line to point C. They are equidistant to each other. I can in fact start using this argument to actually claim that the x coordinate of the axis of symmetry is going to be negative 2, which is obviously not going to be the same as the one that I have here. So I think now I can clearly be confident that the axis of symmetry does not share the x-intercept with the straight line, the graph of G. So in fact, this one is going to pass somewhere earlier, somewhere here, at a value of negative 2. It's very important, it's useful for you to know that this is actually halfway through. It's halfway through and it's very easy for us to work out the solution. Okay, cool. Let's move on to the follow-up question. So the coordinates of C, they're asking for the coordinates of C. C is the point 0, is to 5. Okay, so the next question says, write down the equation of the axis of symmetry of F. Now, the axis of symmetry, like we said, is a straight line that cuts the graph into two equal pieces. Since we've already analyzed that this is going to be exactly between point A and point C, you will see that A is at negative 4. So if I'm moving from negative 4 to a particular point here, I need to move the same distance from that point going to C. If this must be in the middle, there is no two ways about it. The x value has to be negative 2 here, so that you're moving 2 units to get to A, you're also moving 2 units to get to C, which will land you at the value 0. You could have used x of the midpoint is x1 plus x2 over 2, and add the 2x values. One is negative 4, the other one is 0. If you divide them by 2, you're going to end up with a value of x equals negative 2. They said they want the equation, so we're going to have to write it in equation form. The answer is x equals to negative 2. Very easy and straight to the point. Now, 16.3 says we need to calculate the values of A, P, and Q. Okay, let's go back to the sketch and try and ask ourselves, what are these values that they're talking to us about, A, P, and Q? So A, P, and Q are simply the features of the graph. This is what you have in this graph, right? It's all we know about the graph that we are dealing with. Let's clear here and discuss something very important. There are two things that you need to keep in mind. If you've got an equation, which is a graph, that has got x-intercepts, x1 and x2, we're asking for the equation. You'll use y is a into x minus x1, and then into x minus x2. Very important, right? Y will then substitute this x1 here and substitute this x2 here. There should be a random point somewhere with x and y for you to substitute for x and y here and there so that you can work out what the value of A is going to be. Bottom line is this is the approach if you are given two x-intercepts and a random point in your graph. However, if you are given a situation like the one that we have, where you've got the turning point, right? You have to know that the coordinates of the turning point can be used. You can use the coordinates of the turning point to substitute in the equation of the graph to try and figure out what the graph is going to be. You could use y is a into x minus p squared plus q, right? Now, I want you to understand that in this case, both these ideas could work. They could both work, all right? Why? Because if you give me the coordinate f, which is where the graph cuts the x-axis, once more, the axis of symmetry is exactly halfway. I know that the movement from this -2 going there will definitely be 3 units. You're moving from -2, you're counting to 1. That's a total of exactly 3 units, all right? It's going to be 3 units. So I also have to move 3 units going to this one, okay? I need to move 3 units. And when you're moving from -2 and you're moving 3 units, it means you'll end up with the value of exactly -5. So I could have used that with the 0.5, -4 and 5, or 0 and 5 to find the equation of the graph, right? Or I could have used the turning point version and tried to figure out what the solution is going to be. Either one of them is actually going to work out. I'm actually trying to figure out using this one. I'll resort to this one because it looks like it will be much easier for us to find a solution if we're using that one. All right, so what do we know about our graph so far? Quickly, we know that the value of the graph looks like this. We know that it's cutting here at 1. We also know it's cutting here at -5. So it also has a random point here at 0 is to 5. So y is a into x minus x1 into x minus x2. I'll sub x1 and x2. I'll have y is, I don't know what a is. X minus minus 5 is going to be plus 5 squared into x minus 1, not squared. Let's remove that square. We only have one factor. We don't have 2 factors. Okay, now that I've substituted x1 and x2, which are the x-intercepts, I now need a random point. I'll put my y as 5, and then I'm looking for a, so x is 0, plus 5 into 0 minus 1. This is 5 times -1, which is -5, so you get a is going to be -1 eventually, because the product of the last 2 brackets gives you -5, which will then leave you with an a value of exactly -1. So I've got the a value, which is -1. I can then go back and then substitute to try and figure out what the solution is going to be. Now, remember they want a, p, and q. What they have is a into x minus p squared plus q. What do we know so far? I know the a value, right? I can go back and put y is -1 because my a is -1. The x value of the turning points in this question, we know, according to the axis of symmetry, it's -2. So negative of a negative is going to be +2, right? Squared plus q. Now, to figure out what the value of q is, I just need any point on the graph. If I substitute for x and y, if I sub this number and this number, it will be able to tell me what the answer is going to be, right? So I want to just sub those two and see how far this is actually going to take us. Okay, cool. So let's find the point. I can still use that 1, 0, and 5. It will give me the answer to this thing. So my y value is going to be 5. When my x value is 0 plus 2 squared plus q. I'm looking for q. Okay, that's actually 4. So 5 equals to -1 times 4, which is -4 plus q. That's 9 equals to q. Therefore, the equation is actually y is -x plus 2 squared plus 9. So why? Because q is 9, which is what they were asking. A is -1. P equals to -2. And the q value is just equal to +9, which makes sense based on what we're looking at here, because according to this graph, we indeed expected that this graph is going to have a positive value as the y coordinate of its turning point. A very nice question. Absolutely, absolutely exciting. I hope you learned a few things about working with a quadratic function. We're coming back with more. Don't go anywhere.
Did you know that the top 3 tallest statues in the world are of the Buddha? Located in China, the Spring Temple Buddha is the tallest statue in the world more than 1.5 times taller than the Statue of Liberty. The second and third tallest statues in the world also depict the Buddha. They are situated in Myanmar and Japan, respectively.
No one ever asks why we do the weird things we do. Like, why once is never enough? Or doing 2 trips is just one too many? Why do we, before we use these? Or say 5, when we mean 20? Why do we have second thoughts? And think that lift buttons make them go faster? Why don't we walk there? Cross our fingers, touch wood, and struggle to hide our true feelings. At Liberty, we want to know all the weird and wonderful things that make us human, because human beings, being human, are what we make financial solutions for. Liberty, in it with you.
Welcome back to Tenfold Live, proudly brought to you by Mindset and, of course, our very own sponsors, Liberty. Thank you so much for making all of this possible. Yes, guys, do connect with us because this show is interactive. Connect with us on all our social media platforms. We are available on our platform, our app. It's called Tenfold Education. You can get there and just, go into the tutor function, talk to us a bit. Let us know your struggles so that we can help you. You can even stream if you want. And then you can also catch us on WhatsApp. You can just say, hi, Dex, and Dex will just hi back, you know what I mean? And then talk to you about the question papers that you have and everything that you need and want. And also, we are available for streaming on our YouTube channel. It's called Mindset Learn. So do connect with us. We want to help you ace all those exams, and also to help you ace those exams, I have Usbuda on the other side who's helping you with that maths, because I can see those questions are just, Sbuda, do your thing, man.
Right, all right, thank you very much. Hello guys, welcome back. This is Tenfold Live on the show that is proudly brought to you by Liberty. I welcome you and I hope you invited more and more of your friends to come and join us on today's edition of Tenfold Live. We're looking at a lot of questions that you sent to us. It's across all concepts. We're just trying to figure out how do we analyze these questions? How do we work with these kinds of concepts? How do you get answers to these kinds of problems? We want you guys to understand what is going on when you're working with questions such as these ones. How do you read the love letter that the examiners give to you? How do you analyze those questions? How do you answer them? And how do you think about them? Most importantly, we are very much interested in how you think about these questions, right? So we want to make sure that when you're watching what is going on here, you are able, right, to learn what we're doing here. Like you were told, if you download the Tenfold Education app, there's a lot of basics, because most of you always complain about those. You always ask, you will say, we don't know how to work with this. Do I need to know how to actually work with this particular concept? If I don't know, where do I get help? So always make sure you watch the show. If you watch the show, you're definitely going to benefit from what is going on here. All right, now we're going to go to the next question, which is also coming from analytical geometry. Let's go and see what is going on with this particular question. We are told that in the diagram with circle M and circle N that touch internally at point K, right? Kn is the diameter of the circle M, okay? And PQ is the diameter of the circle N and the tangent to the circle M. We're trying to find the equation of the circle that is centered at point M, okay? Okay, cool. Now, let's try and analyze the relationship between what is going on here. We're going to come back to this point with the coordinates 3 and 4. It's a very important point that you can use for analysis purposes, but let's try and park this here for a while and talk about what we see based on what is going on here. There's a couple of very important things that the examiner mentioned in this particular statement. One of them is the fact that these two circles, they touch internally. That means they share whatever the coordinate is. So if you've got a particular x coordinate here, all right, and a particular y coordinate here, those two coordinates will simply be the coordinates that will happen to be points on both the outside graph and the inside graph. Very important. Now, the other thing that I want you to see is if this point N lies on the small circle, okay, it means that the coordinates of that point N are going to be the reflection of these coordinates that you've got here, which means you're going to have negative x and negative y as the coordinates of point N, because it's the reflection across the origin. The distance from M to K should be the same as the distance from M to N. So important for you to keep that in mind. Now, suppose you took the small circle. Let's take the big circle and remove this. I'm going to use A and B, right? We'll take the big circle. The coordinates of the center of the big circle, right, should be A and B. We know that, right? They should be A and B. Now, if I'm writing them, in fact, just for the sake of removing complications, let's just say the coordinates of K, we will put the value A and B here on purpose for a certain reason that I'll show you now. Suppose I call the coordinates of K A and B. That means the coordinates of this point are going to simply be negative A and negative B, right? So that means the equation of the big circle, right, not the small one, the big one, is x minus A squared plus y minus b squared equals to the radius squared. But this A that you have here and this B that you have here are simply the coordinates of the center of the big circle. So x minus that number, which is going to be plus A squared plus y minus the B value, which is going to be plus B squared equals to the length of the radius squared. But what is the length of the radius? The length of the radius is the distance from K to N. That's the radius of the big circle, right? Which can be found using the distance formula, which is a y value minus the y value there. It's B minus the B value at the bottom. That's going to be B minus B, which is simply B plus B, okay? I'm doing the distance formula. Remember the distance formula says x2 minus x1 squared added with y2 minus y1 squared. This is how you work out the length of the distance, right? And that is the length of the line NK squared. And that NK happens to be the radius of the bigger circle. Important. Now, if I do that, you will notice that the x value at K is A, the x value at N is also negative A. Minus is going to be something that looks like this. It's going to be A plus A squared, okay? So I'm going to have A plus A squared, which is supposed to be added with the difference between the y values, which is B minus B, which also gives me B plus B squared. So the length of the radius, the length of the radius of the bigger circle will be 2A squared, which is just 4A squared, plus 2B squared, which is just going to be 4B squared, right? That's basically what we're getting. So that will be the radius of the one that is outside. So I can simply write it here and say this is simply going to be 4A squared plus 4B squared. We're just using the big circle to try and explain what is happening in the relationship between the coordinates that exist in this particular question. Okay, this is assuming that we didn't know the coordinates of K, right? Now, if we continue and you start thinking about the smaller circle now, I'm going to delete this and think about the smaller circle. Let's think about the smaller circle now. The smaller circle has a radius MK, okay? And if you're trying to figure out what that is going to be, very important. If you're trying to figure out what that is going to be, you need to keep the following in mind. It's important for you to keep the following in mind. The radius, they said these things are concentric, and you can see that the diameter of NK is actually the radius of the bigger circle. That means if the diameter of the bigger circle is just going to be twice the radius of the smaller circle, it means you can be able to get the radius of the smaller circle by just dividing the diameter by 2. But what did we get as the diameter of the bigger circle? We got that the diameter of the bigger circle has to be 4A squared plus 4B squared. The diameter is the radius of the bigger circle. We got that, right? Equals to 2 times the radius of the smaller circle, okay? Remember, this has to be inside the square root because I'm now discussing the actual radius, not just the radius squared, since this that you're looking at here is the radius squared. So this is the analysis that revolves around this particular question. You can take out a 4. You're going to have 4 into A squared plus B squared under the radical sign. 4 is going to escape this. You'll have 2 times R as C. If you take the square root of 4, you'll get 2. But the A squared and the B squared will not escape the square root sign, so they will remain inside the square root sign. So you're left with the radius of the smaller circle. If you divide both sides, right, if you divide both sides by 2, you're going to get the radius of the smaller circle in terms of what? In terms of A and B. So let's put it down here. What is the equation of the circle centered at the origin? It has to be x squared plus y squared equals to the radius squared. Let's put the radius squared equals to the radius squared. But we just discovered that the radius squared is just going to be what you get when you divide the 2. So it will be x squared plus y squared equals to the radius, which happens to be the square root of what you're looking at. And when you take that, just put that inside the square root sign, a squared plus b squared, right? Remember, you still have the square that is outside. You end up with the answer x squared plus y squared is just going to be x squared plus b squared. Okay, very easy, not complicated. The only thing that stands out for us here is what is the relationship that exists between the coordinates of k and the coordinates of n. That's the information that we wanted to share with you, the coordinates of a and the coordinates of n, right? The other thing that we also wanted to show was the fact that if you know that n lies on the diameter PQ, which is the diameter of the bigger circle, you can then use that information to then find the value of what? The value of what is happening here, the value of the radius. You can find the radius of the bigger circle. You can also find the radius of the smaller circle. So this is what we're ending up with as the equation of the smaller circle. Now you can continue and attempt to find what the length of what the value of A is and what the value of B is. Since A and B are two unknowns, it will mean that you need two equations to try and figure out what the answers to that are going to be. This here was just based on the general idea of looking at both of them, A and B, assuming that you didn't know what the value of A and B are, and you wanted to relate those coordinates with the coordinates of N, which happens to be the center in this particular question, right? But then let's go back and try and think about the fact that we don't know what A and B are, and we know that they have a relationship. Try and look at a couple of relationships that are existing here. Number one, if PQ, right, is the tangent to the small circle and KN is the radius which passes through the center, it implies that we've got an angle of 90 degrees that lies here, right? Those are actually two perpendicular lines. Very important. That's basically what is going to happen, okay? Now, once you have that, you can then use the fact that the radius of the diameter and the radius of, the gradient of Kn, right, multiplied by the gradient of PQ will just simply give you the value of -1. So we're just stating these facts to keep in mind in case you have to work out what the equation of something is going to be. So these are all the things that are going to happen. Of course, you can be able to find the equation of the other one, the equation of Kn. Remember, this line Kn is a straight line that passes through the center. The problem about it is you don't know what the coordinates of A are, and you also don't know what the coordinates of B are. This is where the point that we discussed comes in. This point with coordinates 3 and 4 will now come in. We'll use it as the value of A and the value of 4. Once you've got what A is and what B is, you can then be able to find the solutions to all the questions that we've been discussing. The idea of putting A and B as unknowns was just to say to you, remember, sometimes you might be given information with with unknown values, and then you will need to know how to relate the two things in order to try and find the solution to this. The last thing that I can perhaps say to you is this. If you know that this point with the coordinates A and B lies on the outside circle, you can steal this as x and y. You can steal this as the coordinates of x and y and write in the equation of the outside circle. Remember what the equation of the outside circle was. It's very important for us to make sure we help you to learn how to analyze these questions. We know that the equation of the outside circle was x plus a squared, right? And then we've got y plus b squared, since a and b are the coordinates of the center, equals to r squared. And our r squared came out as 4a squared plus 4b squared. Now you can steal these coordinates and sub them here and sub this one for y, not where I just put it, but you can sub this one as the y value. Very important. So that means I will have a plus a squared plus b squared equals to 4a squared plus 4b squared. You'll see, again, you still end up with 2a squared, which is going to give you 4a squared plus 4b squared equals to 4a squared plus 4b squared, which confirms the fact that the coordinates of k can be substituted in the bigger circle because it satisfies the equation of the bigger circle since the left-hand side is equals to the right-hand side. So these are important ideas that we want you to keep in mind all the time when you're working with these things. If it's unknowns, you can always be able to find the solution as long as you understand the relationship between the outside circle and the circle that is inside, and you also understand the relationship between the radius of one circle and its tangent. That will actually be easy for you to find the solution. Okay, cool. So now let's go and use the number that was given to us. We're given the coordinates 3 to 4 here. We'll try and find a solution using that as fast as we can. Since we have analyzed what this is all about, we can then go back, right, without using what we have worked out, just for the sake of minimizing confusion. Let's minimize confusion and work with these numbers that we have here. We have the coordinates 3 and 4. I think it was 3 and 4. The coordinates of k. X is 3 and y is 4. So we're looking for the equation of the small circle. That's what the question is asking, quickly. So the equation is going to be x squared plus y squared equals to r squared. You've got the coordinates of the center. The x value is 3. So you're going to have 3 squared. The y value is 4. 4 squared equals to r squared. That's actually 16. And 9, which gives you 25, is r squared. Therefore, the equation of the small circle is going to be x squared added with y squared equals to r squared. That's the equation of the small circle. Okay, cool. Let's move on to the next question. Now, we are asked to write down the coordinates of the point N, give a reason for your answer. Now, if you go back to point N, like I said with my analysis, I said point N is the reflection about the line that you would get if you're drawing a straight line through the origin. It is the mirror image. If you've got K here, and then you've got N here, the other one is a reflection of the other one, because they lie along the line y equals to x. They lie along the line y equals to x. Y equals to x, yes, mx. Okay, so it's the reflection along the line y equals to mx, right? So if I tell you that the origin lies here, whatever you have as the coordinates here, 3 and 4, they'll just swap signs here. It's going to be -3 and -4. Those are the coordinates of K, because it is the reflection along the origin, right, by the line y equals to -x. They lie along the same line y is mx. So very important for you to make sure you keep that in mind, okay? So the coordinates of N is going in terms of the, going to be in terms of the coordinates of K. Okay, so let's go quickly and see how that is going to actually look. Right, so we've got the coordinates of K. We're going to say if K, right, is 3 is to 4, then N is going to just simply be -3 is to -4, because N and K are co-linear. They lie on the same straight line, right? So the gradient you get when you do the difference between the axis with the origin should be the same. You should get the same gradient line between Kn and the origin. So they are co-linear. They lie on the same straight line. The other one is a reflection of the other one. If they lie on the same line, then it makes sense that the coordinates of N are going to be what we have there. Okay, then the last question says, hence determine the equation of N, write the equation in general form. We want to find the equation of the circle that passes through point N. We're going to find that. So let's go back and see what is going on with that. What do we know? Well, we know that this point has coordinates -3 and -4. We can work out the length of nk. We can work out the length of nk from that information. Right. So let's go back and see what will happen. So the equation of the small circle is going to be x minus a squared plus y minus b squared equals to r squared. Okay, we've got the coordinates of the center. It's minus minus, which is going to be +3 squared added with y minus minus, which is going to be +4 squared equals to r squared. R is the distance, okay, between the center and the circumference of the circle. The distance between the center and the circumference of the circle. But what do we know? We know that this circle passes through point K. It passes through this point here. Okay, it's a point on the bigger circle. So we can sub those coordinates of 3 and 4 in that equation. Let's sub that 3 and 4 in the equation for x and y. Right, so where I see x, I'm going to put 3 plus 3 squared plus, where I see this, I'm going to put 4 plus 4 squared equals to r squared. Right, that will help us to work out the length of this. So quickly, that is 9 squared, which is 81 plus, and then the next one is actually 16 squared. If you work out the value of 16 squared, you will always get 256, right? So it's going to be 256 equals to r squared. Now the sum of 256 and 81, okay? 256, if you add it with 81, you will always get the answer 337. And that is the equation of the bigger one, r squared. Therefore, you're going to have x plus 3 squared, and then y plus 4 squared equals to 337 as the value of this. Actually, this is not 9. It's 36. It's 3 plus 3, which is 6 squared, which is going to be 36. Yes, it's 3 squared, which is going to be 36. Let's just quickly use a calculator. You see, sometimes when you do mental maths, you end up making mistakes here. Okay, that's 3 plus 3 squared. We need to add that, yes, with 4 plus 4, which is also not 16. It's 8 squared. Okay, Jesus, mental maths under pressure, you're going to make mistakes. We're getting 100. Oh, beautiful people. We're getting 100. That's 8 squared, which is 64, which is going to give us a value of 100. Sorry for that, guys. Okay, cool. So this is going to be 64. Right, and then the answer is going to be 100. I'm actually pressed for time here. I'm trying to make sure we finish the question. We get an answer of 100. Therefore, the equation of this outside circle is going to just simply be x plus 3 squared plus y plus 4 squared is equal to 100. So that's actually what's going to be the equation of the second circle, and it should be a very, very simple thing to do if anybody asks you, provided you've got the coordinates of the center and you also know what the length of the radius is going to be. A very awesome show indeed. I hope you guys learned a lot from today's program. Thank you for sending us questions. We really, really thank you for everything that you've done for us. We just need to know if we are closing here or we need to actually give back to the producers. But then again, next time when we meet, we'll actually discuss more on this concept. So we're definitely going to make sure we have more and more things that we're going to be sharing with you guys. Invite most of your friends to join us. In fact, all of them. Tell them that we are up and running. We are now taking questions. Send them through to us. A very big shout out to Liberty for sponsoring this program. A big shout out to you guys also for joining us. Until we meet again next time, we will be having more and more fun. Keep checking us online on Facebook. Check us also on YouTube. Send us the WhatsApp message. We are definitely going to take those questions and help you to understand how to analyze them. Remember to download the Tenfold Education app and make sure you have it on your phone. You stream the show live and then you also tell more people about it and you like our YouTube videos. From me, until we meet again next time, bye-bye.